Okay, all right, man. My hair is getting. I shot a video at the beginning of the day. I shot a video at the middle of the day, and I shot a video, and I'm shooting a video at the end of the day, and my hair just gets progressively worse every time. All right, enough about my hair. All right. Anyway, so today what we're gonna do is spend a second day on the explicit geometric sequences. Okay, so meaning taking what we learned yesterday and then applying it to some actual problems. Okay, so this is the last day we're gonna be doing that. All right. Okay. Let's move on. All right. So what we're gonna do is we're just gonna go through a bunch of questions, okay, and try to finish the explicit side for good today. Okay. Explicit for arithmetic, which we did a couple of lessons ago, and today with geometric. Okay, and then so that we could finally move on to something with recursive formulas, and then get the regions questions done. Now, if you notice, right here, I got the formula posted for geometric explicit formula. Okay? All right, now let's start super duper simple. So question number 1. Okay, we'll do the same thing. We'll do all the odd questions. Now, 1, determine if this sequence is geometric. If it is, find the common ratio. Is this geometric? Take a look at this. Yeah, it is. It's multiplied by -6. Have you noticed? Right? So on and so forth. Right? So yes. What's the common ratio? We should use R. Okay? So D is common difference. All right? Looks like that's what people use. And then R is the common ratio. That's my handwriting right there for you. All right? What's the ratio? -6. Okay? Moving on. All right. What about this? Times 4, right? Now here's the problem. Is 36 times 4? No, it's 16 times 4. 4 times 4 is 16. What is 16 times? 16 doesn't times anything to give you 36. And then 36 times, what is that? 36? Hold on. 36, if you double this, 72. So it's nothing. Okay, all right. Nope. Not geometric. All right? So we don't need to find a common ratio. This last one, let me guess, 2, right? Times 2. -2 times 2 is -4. -4 times 2 is -8. -8 times wait, 2, not -2. -8 times 2 is 16. So yes, what's the common ratio? It is 2. That's it. All right, moving on. Okay, given the explicit formula for a geometric sequence, first find. Okay, all right. So given the explicit formula, let me go grab that again. Let me bring that down. So let's see. Given the lights just went off. All right, so here, right here, formula. All right, given the explicit formula, okay, find the first 5 terms and the 8th term. Interesting. All right, so look right here, right? Now, first 5 terms, simple enough, because all I have to do is just follow this formula. So one of the things I want to encourage you, and I was in the same boat not too long ago when I was preparing for this unit. All right, don't get too caught up with the formulas. That's the advice I would give you when you are dealing with the problems in this unit. Don't get caught with the formulas. Take what they give you and then work from there. And if not, hey, go to the reference sheet, okay? Or use the methods that I've been working with you, right? Whether that's the slope-intercept form for the arithmetic or the exponential function, right, with geometric, okay? You can use those, okay? Now, they want to know the first 5 terms. Okay, let's do that. First term, right? So I'm literally just taking the formula. So what does it say? 3 to the nth power, which is 1, right? I'm just taking this power, 1 minus 1. See that? Okay, nothing crazy. I'm just following directions. All right? 1 minus 1 is 0. What's 3 to the 0 power? Right, 1, right? Now let's try for the second term, okay? Again, not doing anything crazy. I just do what I see, right? So that's 2. So that's 2 minus 1, right? I got the 2 based on what they tell me here, right? It's the same letter. Notice, right? 3 to the first power is 3, right? The third term is 3 to the 3 minus 1, which is 3 squared. So that's 9. To the fourth, which is 3, and then 4 minus 1, so that's 3 to the third power, that's 27. All right, I hope you guys can see this okay. let's see, fifth term is 3, and then 5 minus 1, that's 3 to the 4th power. That's, what's 81, right? So far, so good, right? Nothing crazy, okay? Now, they want to know the 8th term, so we'll oblige them. Let's see, 3, and then 8 minus 1, what is that? 3 to the 7th power. I don't know what that is, so I'll just use my calculator. Let's see, 3 to the 7th power, 2187, all right, 2187. That's it, nothing crazy, okay? If you're at home, you know what, let's try this one together, because this one looks more complicated, all right? So why don't we try that? Let me get a different color. Again, right? Again, my word of advice is don't get caught up with the formula. All right? Just look at it at face value. Look at this equation at face value and just do what it says. Okay? That's what a formula is supposed to tell us to do. Now, here it's a little bit more complicated. So here, there's no number in front. There's no initial value. So here, that I think, you know, by the way, this is not necessarily an initial value, but it's telling you where to start. Okay, so that's 2.5. I'm going to use parentheses, okay? So 4, and then n minus 1, which is 1 minus 1. Now, this is simple, but it's a lot of work because they want the first 5 terms. All right, so what I think I'll do is I'll do the first 3 and then give you the 8th term also, okay? Just to save a little bit of time. All right, let's see. So that's 4 to the 0 power, right? So that's negative 2.5 times 1, which is negative 2.5. So there's your first term, okay? So it turns out that is the initial value, all right? Now let's do one more for the second term. Negative 2.5, and then times 4 to the 2 minus 1. All right, let's see. That's negative 2.5 times 4 to the first power, so that's just 4. So negative 2.5 times 4, what's that? That's negative 10. All right, now for the third one, so on and so forth, make sure you do the exponent first. So for the next one, if it's a to the 8th, the third term, this will be 4 squared, so you do 4 squared 16, and then times negative 2.5. But that said, let's try the 8th term, okay? So on and so forth, all right? So I'll put the 3 dots here. All right, negative 2.5, and then 4, and then 8 minus 1. So that's negative 2.5. That's 4 to the 7th power, right? Let's see, what's 4 to the 7th power? It's going to be a gigantic number. Yep, 16,384. So I'll take negative 2.5, multiply that to 16,000, what is it, 384. Let's see what that is, 2.5, negative 40,000 G's. All right, negative 40,960. Okay, all right, nothing crazy so far, right? Everything looks okay, I think. All right, now, I'm gonna bring this down, even though I'm a little uneasy about showing you this question right now, for no other reason than the mention of this word. Okay, but it's related to us because look, they want the explicit formula in the answer. So that's why I think, you know, you guys knowing the explicit formula and that we're doing the recursive formula next, that it's a good idea for me to try to show you this right now. Okay? All right. Now, let's take a look at 11 then. Now, again, don't get too caught up. Okay? Here's how we're going to approach this. Now, the way I want to approach this is by actually analyzing this very formula. Okay? And I'm going to break this down with you guys. Okay? And I'm going to use different highlighters to highlight different aspects of this. Okay? Let me try to use colors I haven't used yet. Now, right off the bat here, this thing, it really hasn't been any different, right? We're still looking for a certain term, right? That's why this is a's of n. So this is no different. If I were to say, hey, give me the 100th term, you would simply write this, okay? That's all this means, right? Now, let's go back then. Here is telling you, look here. Now, if this is the number, what do you think this term means? Do you guys know? What does this term mean? Yeah, it's the previous number. It's the So what they're saying is this, okay? This is very literal language, by the way, okay? So that's why, again, I don't get too caught up with the formula, because formula is just telling, it's a very, well, sometimes not simple, but a formula just tells you what they want you to do. So our job is to figure out what does the formula actually want us to do, and just trying to be clear about that, so that we could do what it wants us to do, okay? Now, here, if they're saying, hey, look, I want you to find, so I'll give you a numeric example. If I tell you, hey, look, I want you to find me the 100th number in the sequence, and the formula says, hey, look at this, an minus 1. Now, let me ask you guys this, right? I'm just going to write this out, the whole thing, all right, using an actual numeric example. So if I say, hey, look, give me the 100th number, here's the direction, right? This is a recursive formula, by the way. So I think this is a good preview for tomorrow's lesson. That's why I'm also deciding to show you this right now. What it's saying is, hey, look, take the term before that. Now, n minus 1, well, right? If I have 100 terms, right, and I want to know the term before that, and they say minus 1, that would be the 99th term. That's all this is. It's basically saying, hey, look, if you want, let me use my magic marker. What it's basically saying is, hey, look, if you want to know what the 100th term is, here's what you do. You take the term before that, the 99th term, and here's what you do. You multiply that, right, by 2. Isn't that interesting? So what does that mean for 2? What does 2 mean then? What does the 2 actually tell you? Yeah, that's the growth factor. I mean, or the common ratio, okay? Growth factor was exponential function, the unit before. Different word, same thing, right? They want to know what's the common ratio for this. So again, let me repeat, because this is worth repeating. Again, what this formula is saying is, hey, the term that you're looking for in our example, the 100th term, this is how you find it. You take the term before that, the 99th term, and then you multiply it by 2. So in other words, what it's saying is this. Since the very beginning, the first term, you just multiply by 2. So the second term is the first term times 2. The third term is the second term times 2. Basically, it's whatever the number before, right? So that's what they're trying to say. Now, how does that apply to us? Well, if this is the first term, right? I'm just rewriting this. What do you think the second term is? Yeah, double that, right? It's the 2 times the term before, right? So that's 4. What do you think the third term is? Times 2, 8, not 6, okay? This is geometric. Not adding, we're not adding, we're multiplying, okay? Don't forget that, right? And then the fourth one is 16. You see where I'm going with this? Right? Everything is 2 times the number before that. Okay, so again, that explains why this is an exponential function, because if you were to graph that, the graph would look something like this, right? Now, what else do I have? What is the question asking for? Oh, first 5 terms. Oh, nice. We answered the first one, and then what's the explicit formula? You can go back to the explicit formula for this right here. All right, you can refer this back, or you could use the exponential function, stat, calc, all that stuff, right? But let's say we stick with this, right? A's of n, so we're just gonna put this in here. Oh, easy. All right, A's of n, first term, right? So A's of n, yeah, checked. I need A's of 1, right? What's the first term? 2. What was I gonna say? Checked, right? And then I got the ratio, which is 2, by the way, in case you haven't noticed, right? Common ratio, and then n minus 1. What is that? Is there a number, I should say? No, just n minus 1. Yeah, formula, it's a formula. That's it. All right, now, let's test this out, because I'm actually want to make sure that I'm right also, whatever I'm telling you. So let's say, let me use a different color. So let's say, I say, well, okay, what about the 5th term? Would it be 32? I don't know, let's try it out, right? So a to the 5th term. Now, I'm just using the formula that I put in as the answer to test my original work. right? I'm specifically focusing on this, right? A to the fifth, okay, let's see. All right, I really hope this is right, okay? Because that would be completely embarrassing if I get this wrong. Now, I think I'm right because, right, I did everything right? 2, 2, yep. N is 5, right? I want to know the fifth term, 5 minus 1, so 2. 2 to the fourth power. What's 2 to the fourth power? 2 to the fourth power, 2, 1, 2, 3, 4. 2 times 2 is 4, 8, 16. And 2 times 16, 32, yay! We were right, all right? We were right, this is good, all right? So, yep, this worked, okay? All right, now I don't know, my phone is ringing. Hold on one second, let me press pause. All right, now I know we're at the 16-minute mark, so now we really technically have only 2 questions. So I really would like you to try 13, all right, on your own. Because that was like, we packed a lot of information in this alone, okay? As a matter of fact, I probably should let you practice number 9 and number 5, but it's okay. All right, now, let's try 13 then. Let me use a different color. Okay, all right, here we go, all right? 13 and then one more question. Now, why don't you try this right now, actually? So look at the example I've set you guys, all right? Try this on your own. So, and then afterwards, I'll just go over this with you, okay? So press pause right now. Okay, all right, and we're back. Now, again, I'm gonna follow the directions, okay? Let's see. All right, now, okay, first term is 2. We know that, right? What's the next term? Is whatever the term is before that times 5, right? So this is the common ratio, okay? Nothing crazy. So 2 times 5 is 10. Did they want the first what? First 5 terms again? Okay. Now, this next one is 5 times that, so that's 50. 5 times that, 250. And then the fifth term is 5 times that, all right? Which is 1250. Let me double check. Hold on. 250 times 5. Yeah, 1250. All right, so far so good. Now, the next thing is we got to take this formula here and just make something out of it. So I'm gonna rewrite this. I don't know why, but I don't know. Good note taking. Now, what do they want to know? They want to know the explicit formula, right? So we're gonna put this back in there. So I want a to the n. First term is 2 times the common ratio to the n minus 1 power. That's it. Nothing crazy, okay? All right, and then if you want to check it, you can check the fifth one. All right, do what I did here. Check the fifth one, and then if it's 1250, then you know that you did it right, okay? So this is not bad, all right? You can check your own answers here. All right, last one, and then we're done. All right, we're almost there, okay? I know this is a long video, okay? So, all right, now, given the first term, and the common ratio, they want the explicit formula. Okay, looks like here we go again. Now, let's see, could we, actually, we could just play this out, actually, right? So here, they're not giving you the recursive formula, but they actually made it easier because they just gave us the first term, right? And then they tell us the common ratio is -5. So, I mean, where do you think this is gonna go, right? So that would be 0.8 times -5. By the way, if you want to pause and just do it, you can, okay? You don't always have to like just wait for me to do this. -4, that's right. A3 would be -4 times -5. That's positive 20. The fourth term is 20 times -5. That's -100. And then the fifth term is -100 times -5. That's 500. Okay, I'm just double checking. Yeah. All right. What else do we need to know? Explicit formula again, right? I'm just gonna look up here. All right, I'll write it again. like that. So a of n is the first term. What was first term? 0.8. 0.8 times the common ratio, which is -5, and then n minus 1. That's it. Voila. That's it. That's how you do it, okay? All right. Well, thank you for your patience. I really appreciate it. And I'm going to sign off here. And tomorrow we're going to work with recursive formulas, okay? All right. Thanks for watching. Bye-bye. OMG, that was so good.